All right. Well, hello, everyone, and welcome. I have 2 o'clock Central on my clock, so we'll go ahead and get started. My name is Ann Nardi, and I work with the North Central Region Water Network and the University of Wisconsin-Madison Division of Extension. For those of you who are not familiar with us, the North Central Region Water Network is a 12-state network. We are extension-led, and we are dedicated to stewarding water resources across the region and working with it to amplify Extension's water work. I am excited to be here with you today to talk about a topic that many of us are interested in learning more about, which is on-farm research. And excited today, we feature a lot of different topics on the current webinar series, but today we have 3 great extension speakers featured for you. So for those of you who have not joined us before, just a couple housekeeping items for you. We have 3 presenters today. Each of them will present, and then following that, we will have a Q&A session. Please put your questions to the presenters in the Q&A panel, which you can find at the bottom of your screen. We will have a dedicated session for that Q&A after all 3 presentations. We may not get to all the questions depending on how many we have today. So if you see another question that you think is relevant or is related to a question that you yourself have, please feel free to upvote that. We will try to get to those questions that are the most popular or the most in demand first. If you're experiencing any technical issues, please let us know in the chat, which should be at the bottom of your screen. We're happy to help you try to address them through that. You can also let us know any kind of technical questions or any questions about the North Central Region Water Network or the extension programs that are featured here today. We're happy to provide some information on that via the chat. If you're having any audio issues, there is a phone-in option that can be accessed by clicking the up arrow on the mute icon and clicking switch to phone audio. This session is recorded, and we will have the recording on our website, northcentralwater.org. You can check that website for all our media archive. We've been doing the current webinar series for the past 9 years, I believe. So we have recordings of all our past webinars on there. And we should have that up on our website within the next 24 hours or so. All right, so I mentioned the current webinar series. We always feature a different water-related topic. And today we have 3 great speakers who are going to be talking about emerging on-farm research. I'm excited to feature 2 different speakers from the Discovery Farm program, one in Wisconsin, UW Discovery Farms, talking about on-farm water quality monitoring, as well as the Arkansas Discovery Farms program, talking about water quality as well as soil health monitoring and kind of the depth and breadth of the research that's happening across Arkansas and Wisconsin on the farm scale. And then Laura Thompson is joining us with Nebraska Extension. Nebraska has a robust on-farm research network. I'm going to be talking about how they're using that network to really promote adoption of precision nitrogen management. So with that, we will go ahead and get started. Our first speaker today is Lindsay Hartfield. Lindsay actually just joined UW Discovery Farms and the University of Wisconsin-Madison Division of Extension in January. Prior to that, she was at Iowa State University, so still within the North Central Region Extension and Land Grant Network. And her research is really focused on water quality, nitrates, and tile drainage. I'll let you read her full bio there, but we are excited to have Lindsay here to talk a little bit about UW Discovery Farms and their water quality monitoring work. So with that, I will stop sharing and hand it over to you, Lindsay.
Sounds good. Thank you. I will get my screen shared. Are you seeing that? Okay.
Looks great.
Okay. So I will go ahead and get us kicked off today. And like Ann said, I'm representing UW Discovery Farms today and highlighting our on-farm water quality monitoring, which has been going on for a little over 20 years now. So before getting into the details, I did want to start by giving an overview of what Discovery Farms is for those who are a little less familiar about what Discovery Farms programs entail. So the Wisconsin Discovery Farms program was started back in around 2001, and they had really 3 pillars that they tried to focus around, being the first one being farmer-led, the second being on-farm research, and the third being outreach. So as part of that, then, like I said, the goal was to get research onto real working farms in the state of Wisconsin. Prior to this, the research was really primarily being done on our university research stations and farms, so on the smaller scale plot scale studies. And so there's a lot of interest from farmers across the state to get some research going on full-scale farms. So as part of this, then, we really have a focus on incorporating farmer leadership into our program, and also to get them a seat at the table, especially during state level water quality conversations. And as part of our on-farm research, then, we also want to be able to support farmers to implement practices locally on their farms that work in the area they are located, and also then to verify the effectiveness of the practices that they are implementing. So a little bit more then specifically about the UW Discovery Farms program. So like I said on the previous slide, it began in the early 2000s, but the map on the right is showing where in Wisconsin we have had studies in the past. And I will wrap up this presentation by showing a map of where we are currently monitoring as well. So initially, our program started by having a goal of really just learning and understanding typical ranges of runoff, soil loss, or nutrient losses that we can see in agricultural settings in the state of Wisconsin. Before this, like I said, the research was really on smaller scales, on research stations. And so we wanted to see what was going on if we put this at a full-scale farm level. So since then, we've been able to now get into some more targeted research questions. So for example, if we add a cover crop to a field, now what kind of water quality benefits can we see? But also more recently, we have also moved into what we call our project partner model. Before 2018, all our water quality monitoring, sample collection, that was all done by Discovery Farms staff. So when we had a runoff event, a staff member had to be out to that site to get those samples within 24 hours and then get those sent into the lab to be analyzed. So this kind of limited where we could have studies because we needed to have someone fairly nearby to be able to get those samples in a timely manner. But we've now moved into working with a local partner who will, as long as they're available, get those samples for us, get them sent into the lab, and help to maintain those sites as well. And this has been a mutually beneficial relationship for us. It helps us to cover a broader area of the state, but it also helps to build a more of a local connection to the projects as well for those people in the area. So then I also wanted to highlight what kind of monitoring we have done through UW Discovery Farms. So the main part or staple part of our monitoring has been this edge of field surface monitoring. And the image on the left is showing what our surface monitoring stations look like. And we do this through a partnership with USGS. And so through that partnership, we have the shared goals of being able to provide credible data collection on these farms, some credible data analysis, and also to be monitoring year round, even during those really bitterly cold months in Wisconsin winters. So this edge of field surface monitoring, they're set up at the edge of the field at an area where the water naturally is concentrating. So where we have a natural concentrated flow path, and then to intercept that and collect our samples. But we have had several other types of monitoring as well. So we do some monitoring of tile drainage. Our new type of monitoring that we're working on is nitrogen leaching using pan lysimeters. And then there have been a few projects that we call or refer to as special projects. So these are more of a specialized topic and shorter term studies usually. So one being nitrogen use efficiency is more like our typical runoff or nutrient analysis, but looking at nitrogen use efficiency in crops. But with that, I will transition now into discussing and highlighting some of our research that we have going on right now in Kewaunee County, Wisconsin, looking at grass waterways. So for those who aren't familiar with Kewaunee County or the counties of Wisconsin, Kewaunee County is located going up into the peninsula of Wisconsin, right along Lake Michigan. And this is a really dairy heavy area of the state. So we have 2 sites in this county that we're monitoring, and both are operated by dairy farms. They both feature a dairy cropping rotation. They have heavy clay soils, but both farms are practicing no-till with cover crops. Differences in the 2 sites, they're called KD1 and KD2. I'll call them site 1 and 2 probably for simplicity's sake. But the first site did not have a grass waterway when we began monitoring, and it was located further from Lake Michigan. And then the second site had an existing grass waterway, but it was an older waterway that was showing some signs of needing some repairs and reshaping. And that one's located closer to Lake Michigan. And then here showing the crops that have been on the field, said dairy cropping rotation. It's been pretty much corn silage the entire time we've been monitoring, with the exception of 1 year at the KD2 site. So in here, I'm showing some pictures of the waterways for those who maybe haven't seen waterway installation or repairs. So this was done in the summer of 2020. So we had 2 years of monitoring before the waterway was added at the first site and renovated at the second site. And then we have 2 years after that renovation and addition of the waterway. So jumping into the data now, here I'm showing precipitation. So the main takeaway here is that both sites we've been seeing at least equal to or above average precipitation when we look at the 30-year average, which is the gray line going across those bar graphs there. And also we always see that KD2 has higher precipitation than KD1 regardless of year. And we believe this is a factor of the being closer to Lake Michigan. So there will be lake effect snow, especially during the winter months. So we think that lake effect is contributing to some higher precipitation at that site. Then when we look at runoff, we see that that's a lot more variable from year to year. So in Wisconsin, there's quite a few different factors that will go into when we will see runoff. Here we have it broken down into frozen or non-frozen soil conditions. So you see some years have more of that frozen soil condition having runoff than other years. So when we have runoff during the frozen soil period, that's a factor of how much snow did we get that winter, how quickly did it melt in the spring, did we have precipitation on top of snow melt happening, and then during that non-frozen soil condition, that'll be a factor of did we have a lot of rain beforehand where the soil is saturated already, or did we just have a really large rain event that generated that runoff? Takeaway here, pretty variable runoff from year to year, and that's really just a factor of the conditions from year to year. But now when we look at soil loss on this slide, I think the picture gets to become a bit clearer of how these waterways do work. So here I have it divided before and after the waterway was added at KD1 and after it was renovated and reshaped at KD2. And so you can see that there's a break in the graph. So there's a break around 4,000 pounds of soil loss per acre per year. So when we look especially at that KD1 site, we had really high levels of soil loss, close to 50,000 pounds of soil being lost per acre per year before having that waterway added. After adding in the waterway, the soil loss has decreased tremendously. Statistically significant reduction in soil loss for both of those sites. So then when we look at how that relates back to nutrient loss, I'm going to focus in on phosphorus for the sake of time today. But here I have it broken down into dissolved and particulate phosphorus loss. So the particulate phosphorus, that's the darker purple color on these graphs. And you can see that makes up a lot of the phosphorus losses, especially before we added or repaired those waterways. Reason being, particulate phosphorus loss, that is the form that is going to be stuck to our soil particles. It'll move with that soil. So when we have a lot of soil loss, we'll see that particulate phosphorus loss as well. So looking at this again, we can see, especially in that KD1 site, that particulate phosphorus especially has really been reduced through that addition of that waterway. So now I will, for the sake of time, wrap it up and just kind of pull this all together. I did want to discuss what's coming up next for Discovery Farms and what we're doing next with this particular project. So here, if you can see my laser pointer, I'm highlighting where Kewaunee County is for you now. And we're in our 5th year of monitoring now. So we're gonna continue to get some more data to back up how well these waterways are working for us in this region of the state. And then some other projects we have going on the border of Juneau and Sauk County, these two here. We have 2 sites. The goal of those studies was to look at cover crops and different manure application there. Then up in Langlade County over here, this is a new type of area that we're studying. So we want to verify runoff and nutrient losses in seed potato production. That's pretty heavily in that area prevalent. And also looking at cover crop use there. Then here in the middle of this north central Wisconsin, Marathon County, we're comparing a grazed pasture-based dairy versus a large dairy that's practicing year-round soil cover on their row crop acres. And then a new project area for us is nitrogen leaching. So that's going on over here in Pepin County. We're in our 2nd year of that study, looking at understanding nitrate leaching in dairy cropping systems. So that area of the state has concerns about that nitrogen getting into our groundwater. So we're looking at different practices to reduce that nitrogen leaching. And we are adding into 2 sites in these 2 counties here this summer and this fall as well to continue looking at nitrogen leaching below that crop bed zone. So with that, my contact information is on the bottom of the slide, but I will turn it over to Mike for him to discuss the Arkansas Discovery Farms program. And I will stop sharing my screen.
Thank you so much. I'm super interested to hear more about the nitrate leaching, as well as I think the results of that pasture-based versus a concentrated feeding operation with soil cover will be really interesting. Okay, next up is Mike Daniels. I'm really excited to have Mike here. So we traditionally work with most of our partners in the North Central region, but we work very frequently with Mike and Arkansas Extension through our collaboration with Sarah 46 and the Mississippi River Basin. So I'm very excited to work with him. We work with him on several different projects, working on farmer engagement and farmer leadership, and excited to hear more about his research and leading the Discovery Farms program. So Mike, I'll hand it off to you. Thanks for joining us here today.
Thanks, Ann. And let me just say, Lindsay, you did a great job, and you are going to be a tough act to follow. But I think Lindsay did a great job of explaining the Wisconsin Discovery Farm program. And that's how the Arkansas Discovery Farm program was initiated. We sent some people up to review their program. We came back, we shared it with Arkansas Farm Bureau. We took a delegation of about 20 farmers from Arkansas Farm Bureau up to Wisconsin. And we kind of got out of the way and let the Wisconsin farmers talk to our farmers. And that's really how our program got started. I messed up. I tried to answer a question live while Lindsay was talking. Ed Weinberg sent in a question about, do we have any current CIG grants? Ed, I will just tell you in Arkansas that we currently have 3 state CIG grants going on our Discovery Farms. And in fact, One of them is trying to extend our grazing season and using cover crops in a pasture-based system. And that's actually being led by Bronk Finch. And I think Bronk is on today. And so shout out to him. We also have one on trying to help farmers improve their soil health. And I'll talk about that a little bit more. And then we have one on trying to use biochar as a soil amendment to increase our water relations, soil, water, plant relations in our soils. And I'll talk about that a little bit more in a minute. I did want to always like to look at the participation list, and we do have some people from Arkansas on. Tate Wentz, our non-point source pollution director for the state of Arkansas, is on. I appreciate him being here. Alice Weeks, who's helped me set up some discovery farms. We do a lot of work with Alice through the conservation districts. And then unfortunately, she left our state, but Bregan Anderson is on. She did a great job while she was in Arkansas. And in fact, she helped us work out and was able to give us a lot of resources so that we can start testing automated irrigation controls to reduce the amount of runoff that we have on our farm. So a big shout out to her. I also have another blast from the past. He worked in Arkansas that I saw on the list, but Dr. Tom Sauer is joining us today. I haven't seen Tom in years, but I worked with him early on when he was at Arkansas. So good to see him on. I wanted to talk a little bit about some of our new initiatives. We've been doing water quality monitoring, much like Wisconsin has in the past 10, 11 years now. But we have moved on to try to do some other things. But before we do that, we don't have a slug of money coming to us every year. We have to go out and find money. So we do it through grants and donations and working with private industry, working with government, working with our commodity boards, working with, and quite honestly, one of our biggest funders is NRCS. They are a huge partner of ours, and so is the state of Arkansas. So we've been very fortunate to have a lot of interest from this group. In Arkansas, some of you may not be familiar, but the issues that we really face in eastern Arkansas is our groundwater withdrawal is greater than recharge. And so we are dropping, and we call it critical groundwater decline, but we are dropping our groundwater too quickly to meet irrigation needs. For you guys familiar with Wisconsin, I once calculated what our daily irrigation needs were in the Lake Mendota there in Madison. It would only last 2 weeks to supply our daily irrigation need before we'd have to fill the lake up again. And that just gives you an idea of the type of evapotranspiration that we have in our climate. Soil erosion, soil quality, soil health. You know, when you look at our TMDL list in Arkansas, the biggest thing is impairment due to sediment. And so turbidity it's actually turbidity, but the cause of turbidity in a lot of cases is sediment. And so we're working on that. We're also working, as Ann said, across the 13 states that border the Mississippi River. And really our primary interest so far on this has been how can we reduce nutrient losses and what are our nutrient losses? And I'll show some of that data pretty quickly. We have quickly moved into climate change resiliency and services. We are trying to help position our farmers to take advantage of things that they may be able to offer in terms of climate change. We've got several new of the commodity partnership projects going on. We're always concerned about profitability, and I think we find that the natural resources we depend on are very important to our profitability. And farming obviously leans very heavily on soils and water. Another area that Bill Robertson's retired now, but as a cotton specialist and watching what was going on in the cotton industry, we've really started doing some documentation, sustainability documentation for supply chain. But the biggest thing and the biggest thing that makes this program work in Arkansas is involving solutions in involving farmers in the solution process and giving them making this their program. We just provide the science on farm for them, and I think it's very important to involve them in the process. And I really think sometimes the best solutions don't come from me or others; they come from the farmers themselves. And so we always want to keep the farmers involved in the solution process, because I think they know their land the best, they know their capabilities, And when you really get them engaged, they may come up with the best solutions. Our program started out with only 4 farms back in 2011. We've now expanded to over 15 farms. We've also added things like 2 horticultural farms where we're looking at how to help horticultural farmers irrigate more wisely and reduce runoff from peach orchards and from strawberry production. But primarily we're in rice, soybean, corn, and cotton and row crops, and then poultry and beef. And we have 1 grazing dairy that we're also taking data on. These are the guys, not all of them, but some of them, but these are the guys that make our discovery farms work. They accommodate us, they work very closely with us, and they've been very engaged, and they challenge us. They very much challenge us. And so it's been great relationship working with these farmers. And we just can't talk enough about how important they are in this whole discovery farm process. The things that we monitor, one of the things when we first started discussing this with farmers is farmers encouraged us to take a more holistic point of view, which is very challenging because, you know, we've all been trained in research to break things down, isolate things so that we can have a control. And we don't have a lot of controls on our discovery farms. We're just there in kind of an observational mode. And we get criticized for that sometimes, and sometimes it's harder to publish papers. But on the other hand, I do think it prompts a lot of research questions. And I think when you think about the scientific process, we all know it starts with observations and then forming hypotheses. And so I think that's one of the powers of this, but it also gives us a better idea of what's going on a field scale and real world. But we measure field hydrology. We want to be able to measure and quantify every drop of water that goes onto that field and every drop that leaves that field. And we obviously look at nutrients, the sustainability metrics, and we're now characterizing each of our discovery farm fields and then some that we call satellite farms, where we're not doing the water quality monitoring, but we're doing the soil health. And we're talking to farmers for the first time ever in Arkansas Extension about infiltration rates, water aggregate stability, those type of things. And we also understand that in Arkansas, we grow a lot of rice. We're the nation's largest producer of rice, and we can produce methane. But we also know that we have the ability to store a lot of carbon. And so, and we have a lot of potential. So we're hoping that we can participate and help farmers benefit from providing climate change services. So I'm now working with Dr. Chris Bry on both the soil health and Trent Roberts on soil health. We have a lot of faculty involved in this program now. And Chris is also doing all of our greenhouse gas monitoring now on our farm. So we're looking at carbon sequestration and greenhouse gas, and then selected. And this is just the idea of some of the type of monitoring that we do. This up in the upper right-hand corner, we have irrigated flow meters equipped with data loggers, and we can program those data loggers to collect information down to a minute of when water's coming on through irrigation. We use the ISCO samplers. We have found that in a lot of our row crop situations, the trapezoidal flumes probably work the best because they allow a lot of the crop residue that floats in the water to go right through that flume, and they're self-cleaning. And so they've been really good. We also just do a lot of pipe monitoring because a lot of our rice fields are drained by pipe, and we use the Manning's equation. We also use a pressure transducer equipped with a little Doppler radar that will give us an idea of the velocity. And so, but if they have surface water on their farm, we're also sampling that. Now, I talked about we've been monitoring nitrogen runoff, load versus runoff. And this is just some data from cotton, but I think we're seeing this trend over all of our site years, is that we see this relationship. In this case, these were a pretty good fit for linear, but other cases it may be quadratic. But we're seeing that the loss, the seasonal loss of nitrogen and phosphorus with increases linearly or quadratically with runoff. And I think everybody always focuses their attention on, well, how much fertilizer are you putting out? And it is true. You have to have a source, and we don't want to put out more than we need, but we also have to consider the transport. And I think the bulk of our research across all the states, across all this type of research is focused more on the source than the transport. And I think that and there's a good reason for that. It's easier to characterize the source. We have some very historical success stories with soil testing. But I think if we're going to make progress in this area, we also have to start figuring out ways that we can better manipulate the runoff volume, especially in our state where we have a lot of poorly drained soils. And it is tough to do that, and it's going to take time. And we're trying to do it with soil health. And I don't have the slide, but if you put over all of our monitoring points from across all of our sites over the year, well over probably getting close to 1,500 data points, individual data points, storm-based event data points, we're finding that when we can total that up during the seasonal, looking at the growing season to harvest, that we're probably losing about a little less than 5% of the nitrogen and phosphorus that we apply as fertilizer. That's just simplifying it a little bit, because not all the losses come directly from that fertilizer application, but that's just to kind of put it in perspective. And even though we produce higher rates, I mean, we add higher rates of nitrogen in corn and higher rates of phosphorus in corn than we do soybeans or cotton. What we find is that the percentage loss is fairly constant, even though the numerical loss, the quantity, is a little bit higher when we add more fertilizer to those crops. And so I think we do a good job of trying to match the need to the crop needs. And but again, we've got to learn how to manipulate runoff and how to reduce runoff by increasing our soil health. And one thing we started, and this was not my idea, but this was Nathan Slayton, our soil test director. He said it would help me a lot if I knew what was running off in the edge of these fields. It might help us better come up with better potassium loss. Now, potassium has never been documented in the literature as an environmental issue in water quality. But we all know that potassium is a fertilizer that we put in larger quantities than phosphorus in most cases, at least for our crops. And what we found after 10 site years was that we were losing about almost half of what we were applying as fertilizer. Now, we know, looking at the patterns, that not all those potassium losses came from the fertilizer we applied. A lot of it was already in the soil or in the plant residue. And one thing we know about potassium, it never gets incorporated into the plant cell. It's always soluble in that plant. So when you harvest and you have plant residue on the surface, that potassium in the wintertime can be leached out and moved on down the fields. And one thing that we have different in our row crops is that we have long, flat fields, less than maybe 1% slope, sometimes a half mile or longer. And so that in some ways helps us from nutrient loss, because we don't generate a lot of energy to gouge or that sort of thing. But the other thing is when we put this at 2022 fertilizer prices, this loss equated to about $15 per acre. And it would be the same amount that the losses that we were seeing, we could produce 2 bales of cotton in the next growing season if we could keep that potassium in place. And so the Soil Test Review Board has funded one of our new professors, Dr. Gerson Drescher, to work on what can we do to keep potassium in place. And then this is just a picture of the cover crops in cotton. We're still slow to adopt cover crops. And I think it's because we don't get a quick response. But one thing we're finding consistently, and these are soil moisture sensors where we did side-by-side comparisons where we had a cover crop and no cover crop. And after 2 or 3 years of having cover and no cover, if you look at the moisture, and all these are our soil moisture use curves or soil moisture sensor curves over time. But in all of our crops where we had cover, you can see that the patterns out here in July, when it gets really dry, that these profiles down deeper, 12, 18 inches, are starting to mimic the 6-inch, which is the red line. They're starting to mimic somewhat the 6-inch, which indicates to us that we're using water down at 12 and 18 inches. And we have very shallow soils before we hit a hard pan. And so year after year, cereal rye is opening up our profile and allowing us to use water at deeper depth, which is it may be important to our groundwater situation and our need for irrigation. This may allow us to stretch the time out between irrigation so that we can save some water. But if you look at the no cover side, water is down there, but it's pretty flatline compared to our 6-inch sensor. And which tell us that the roots aren't getting past that restrictive layer. And we've tried mechanical tilling deep to get that water down there, but we find that the mechanical tilling will close up after about 8 months. And using the cereal rye year after year is continually keeping that profile open. And I know I'm about out of time. I think the key results we've seen so far is we were shocked by the amount of potassium loss and runoff. That's not really a water quality issue, but it is a profitability issue. We are seeing improved water use with depth by cash crop where we have cover crops. We are documenting the cotton sustainability. We're also looking at soil health, and we're really starting to put an emphasis on soil microbiology. We've never measured what kind of micro populations are in our row crop fields. And the one thing about Discovery Farms that I can't emphasize is how impactful of an educational platform it is when you can go out to a Discovery Farm and let a Discovery Farm on his own land motivate and educate other farmers. And with that, I'll turn it back over. And thank you for attending and being a part of this. If you need more information, here is some of our information. I'll stop sharing now.
Thank you so much, Mike. Super interesting stuff, especially about the potassium. I had not seen that before. All right, we're going to move into our third presenter. I'm very excited to have Laura Thompson on the line with us today. Laura Thompson is with Nebraska Extension, and she is the coordinator of the Nebraska On-Farm Research Network. You can read some of her full information there, but she has a very interesting background as both a pilot and certified crop advisor, as well as working on her family grain farm. So she's going to be talking about the Nebraska On-Farm Research Network and specifically how they're using that network to talk about precision nitrogen management. So Laura, I will hand it off to you.
Okay, great. I'm just going to share here. Okay, great. Can everyone see that?
Looks great.
Okay, perfect. Well, thanks for the opportunity to share with you today. I'm going to be sharing about our Nebraska On-Farm Research Network kind of in general, and then diving into our project, looking at how we can promote adoption of precision nitrogen management, kind of a special effort through our On-Farm Research Network that we've had going now. So, let's see, there we go. So first, just some overview about our On-Farm Research Network in Nebraska. Really, we see this as an excellent merger between the research and extension missions of the university. So farmers are actively involved in conducting research. This is happening across the state in a number of different locations that go well beyond what we have research stations in the state. Which provides a really robust data set to help inform recommendations. So we're collecting a lot of great research data, we're getting a lot of information to inform recommendations, but at the same time, those participants, those farmer cooperators are having a really great opportunity for transformational learning, which can help increase their adoption of those technologies. So they're seeing how these things work in their own farms, with their own production systems in their climates, with their equipment. And so that really helps them evaluate how those products or practices that they're evaluating might work in their operation and help them make that decision about adopting them. So our history of our on-farm research program in the state was launched in 1989, so over 30 years ago. And since that time, had numerous efforts, kind of started in a localized counties, had more efforts expanding into other counties around the state. And then in 2012, everything really came together under the umbrella of the Nebraska On-Farm Research Network, which was expanded to really focus the program as a statewide program. And since that time, really have had growing participation. So you can see starting back in 1990, we had a group of 12 pilot growers that signed up to participate, and each committed to comparing some practice that they were interested in versus something that they normally do. A lot of those at that time were looking at converting to no-till. So that's what a lot of those early studies were. And now we have a huge expansion of topics that people are looking at, and generally have over 100 trials that are being initiated each year. As Mike mentioned, some of the partnerships are really key to help us sustain and grow the program. And so our commodity organizations within the state, the Nebraska Soybean Board, Nebraska Corn Board, our Corn Growers Association, and Dry Beet Commission are really instrumental in maintaining and sustaining the program. Along with that, though, there's a host of other industry, natural resource groups, other organizations that are involved in different projects from time to time. So I did want to just highlight a little bit of the impact of participating in on-farm research. So since we have this really nice long history of over 30 years of participation or of an on-farm research program, we did a long-term impact survey where we did in-depth interviews with farmers who had participated sometime during that time frame, and really asked them about their motivations and what they changed or what they did as a result of participating. So 95% of them found that their research results were reliable and trustworthy, which is amazing. We also found that 75% were putting their results into practice, or they had put their results into practice. So this is more than just, I intend to put these results into practice. We're actually able to document here that they did utilize their results and implement those changes. And then we also asked them about the economic impact of participating in on-farm research. And we found that on average, they had gained $31 per acre by putting their results into practice. So really positive findings to help us have confidence in the method and the strategy of on-farm research. So I want to turn now just a little bit to some of the experimental designs. And I think this is where our program is maybe a little bit different than the ones that have been shared so far today, a little bit different approach in this particular effort. So we're using randomized and replicated trials, and we're imposing treatments in the farmers' fields. So this is just a basic example looking at a strip trial. Here, maybe we're comparing A being something the farmer normally does to B, something they're interested in trying. And we use, as you can see, there are multiple replications of those, and we randomize those through the field. So this would be kind of the basic strip trial approach. And so that's kind of our standard. But we can also take it to a more advanced level. And so this is where we kind of start looking at precision experimentation. And so here we're looking at how we can utilize the technologies that producers have in their operations to really gain even more information and provide greater convenience for producers. So here you're seeing a trial that is looking at different seeding rates in this case. And you can see we're deviating away from that standard strip trial approach. So we're moving to these a little bit smaller plots. These are generally the width of the implement by about 400 feet long as a minimum. And we designed these to fit the unique fields and situations. And so these are prepared in advance, and then those different rate trials are implemented on the go using the grower's variable rate technology. So here you can see seeding rates changing on the go on that monitor there. This can be done with nitrogen rates, and other products can be logged this way as well. Then at the end of the year, when we're collecting yield data, we also are collecting that on the go with yield monitors and looking at how that yield data that yield corresponds to those different rates that we put in the field. So we're able to look at how something like nitrogen rate or seeding rate responds differently in different portions of the field. One of the benefits is we're able to test some lower rates with less risk to the growers. So they're only involving a small amount of acres compared to a field length strip, and get some really good information about that. And then we're able to just really add convenience. So this is all happening on the go. They're planting as normal and those rates are changing, and they're harvesting as normal, and we're collecting the data on those rates. So that's kind of the basis of the precision experimentation, but we can have a number of different designs. And so here's one where we've kind of taken that concept and just expanded it to the entire field. Here, looking at seeding rates across the entire field in a checkerboard design. This is one looking at nitrogen rates across a landscape. And here you can see we've placed blocks of different nitrogen rates within different areas of the field. So on this left side of the field, we have higher elevation, on the right side, lower elevation. So we can start looking at yield response to nitrogen as influenced by that topography. And then in Nebraska, where we have a lot of center pivot irrigation, we also have the opportunity to start looking at putting in treatments using center pivots. So this is where we're using a remote sensing based method to determine nitrogen rate called Sentinel. And that's what the grower is evaluating. And so in some of these sectors of the pivot, we utilize that data-driven approach. And in some sectors, the grower just puts on what their normal rate is. And so this also can all be automated, and we're able to collect yield data from within each of these sectors to determine the impact of those approaches. So really opening the doors for a lot more complex experimental designs, answering a lot more in-depth questions, and allowing producers to really maximize the use of the technologies they've invested in to conduct research. So with that, I want to kind of turn now to focus on our project in particular about promoting adoption of precision nitrogen management. And so this is funded by a CIG grant, a CIG on-farm grant. And the goal is to provide farmers with access to technologies that can improve their nitrogen management. You can see here on the left some of the technologies that farmers are able to select from. So we have crop model-based tools. These are commercially available tools. For example, Adapt-In, remote sensing-based tools. We also have enhanced efficiency fertilizers, things like inhibitors, and then we have biological products. And so our goal is really to help producers identify what might be that next level that could improve the nitrogen management in their operations. And so that's where this really ties into this critical issue of groundwater nitrate and improving our nitrogen management. So the idea here being, how can we increase our nitrogen use efficiency? How can we make more data-driven nitrogen management decisions to reduce nitrate leaching into the groundwater? So within each of these technologies, we're providing hands-on experience for the farmers, so they're getting to try these technologies out. We're providing technical support and providing financial compensation to reduce risk. So we're trying to remove as many barriers as possible that would allow producers to really jump in and try these products without the financial risk, without some of those questions of the technical, how do I use this? We're there supporting them and helping evaluate how it performs in their operation. And so after they select that technology, we work with the growers to establish on-farm trials. And we're doing this using that precision experimentation framework that I just shared. And so we're documenting the agronomic impact of these technologies, economic and environmental, and comparing it to their typical management. So that really allows them to see, is this going to be an option that improves upon what I'm doing in my operation? And so our goal here is really to provide a flexible framework. We're not prescribing exactly which technology producers need to try. We're trying to help them select a technology that's the best fit for their operation, that they're most likely to adopt, and then help reduce barriers to implementing or trying that. So this project is now in kind of going into the third full year of field experiments, and we've had a number of sites all across the state. You can see some of those dots, but we'll be completing by the end of this season over 120 trials looking at these technologies on farmers' fields. So rather than trying to share results across all these different technologies, I've chosen to just highlight a couple case studies. And so I want to just introduce you to a couple of the producers that have worked with us and the technology they selected and what they found. So the first one is John, who farms in Western Nebraska, and he has had purchased crop canopy sensors to mount on his high clearance applicator to sense crop nitrogen need. He had purchased those, but had been not very comfortable using them or uncertain of the benefit of them, and so hadn't been widely using them. So we worked with John to help him evaluate those. So when we compared what he had typically been doing for a nitrogen rate to what the sensors had been doing, or what the sensors recommended, we found that the sensors recommended 80 pounds, about an 80 pound per acre decrease in nitrogen. So already a nitrogen savings here. When we look at the yields, we found that the yield was very comparable between the grower's typical management and the sensor-based management. And then when we look at profit, we found that we were actually able to increase profit by about $49 per acre using the sensor approach. And so this is what John said after participating for a year. He said, the sensors see what we can't and help verify what we think we need for nitrogen is often not the case. And participating in on-farm research has forced me to continue to use the sensors and help me really evaluate our methods. So here's what those sensors kind of look like as we go through the field. You can see the sensors on the front of the machine here. And at the top here, we're looking at normalized difference vegetation index. And then at the bottom, looking at pounds of nitrogen that is being applied. And I'm not sure if I can make this play. Here we go. Just jump ahead here a little. Okay, so on the top here, you're seeing that sensor reading that as we're sensing the crop. And so one of the key differences here is that we're not just applying a uniform rate across the entire field. We're responding to the crop's nitrogen need as it varies across the field. And so that's making our nitrogen management more precise. So here we're seeing right here, we've got an area where we have lower sensor readings, and that's corresponding to an area where we have higher, we then recommend a higher nitrogen application. And so that nitrogen application is going on in real time as those sensors are reading that. And so we're able to make a much more data-driven, data-informed decision about nitrogen management. We're able to respond to those conditions throughout the field. And in this case, we were able to reduce overall the nitrogen rate as well with no real impact and an increase in profit. So I'm going to kind of skip ahead just a little bit here, but we have tested this method across numerous sites around the state and saw that nitrogen efficiency increased in 87% of the sites. And we saw that profitability increased in 69% of the sites. And on average, that profit increase was about $51 per acre. So the other farmer I wanted to introduce you to is Doug and Tony, and they farm in central Nebraska and put on a lot of their nitrogen through their center pivot irrigation system during the season. And so they were interested in testing using remote sensing to help inform their fertigation. And so this is kind of very briefly what this process looks like. We established some areas of low and high nitrogen in the field that give us an indication or serve as a calibration point. And then we're collecting that drone imagery or satellite imagery throughout the season. We're using that imagery to create our fertigation decision and determine if we need to apply nitrogen and which parts of the field need nitrogen. And then we can repeat that weekly. And so that's a real benefit to this approach. Since we have that center pivot irrigation system, we're not constrained to just applying nitrogen at one time. We can continue to keep making that decision week after week and assessing if more nitrogen is needed or if it's sufficient. So this is just showing.
Sorry to interrupt. I think we have about a minute or two left.
Oh, okay, great. So we'll jump into their results here. And compared to what these growers had typically been doing for their nitrogen management, using this more data-driven, sensor-based fertigation, they're able to decrease their nitrogen by about 100 pounds. When we looked at yield, we saw absolutely no difference in yield. So that was excellent. And then, of course, due to that decrease in nitrogen and no yield difference, we had an increase in profit of about $80 per acre. So really a win-win. We're applying less nitrogen. We're timing it with when the crop needs it, which is going to reduce that nitrate leaching. And so the growers said, this project has proved to me that with the sensor-based approach, we can get by with a lot less nitrogen. These growers are now looking at implementing this. This technology is now being commercialized, and they're implementing this more broadly across their acres. So a lot of potential impact on reducing nitrate leaching. So I'll skip over this for the sake of time. Wanted to share just a couple impact statements from some producers here. As we meet with these producers and share the results with them, one producer said, I'm shocked by the results. I was planning on purchasing more fertilizer for this year, but now that I see these results, I don't think I need to buy more. So just helping them be aware of where they were at with their nitrogen management. Another grower, I've had crop canopy sensors for years, but didn't feel confident using them. Now that I've seen results, I will use them farm-wide. So really just trying to come alongside them and help remove barriers, help them assess those technologies and see how they'll fit in their operations. So all of our research is published each year in PDF copies of our research book, which can be found online. And then the growers share their research results as well, which is a really fun highlight each year to be able to hear those research results at our meetings. So if you want to access any of that information, our on-farm research website is here at farmresearch.unl.edu. We have all that research results that are published there. And with that, I'll leave my contact information if anyone wants to get in touch.
Thank you so much. I'm sorry we had to cut that a little short. I know we're running low on time for questions, but I really appreciate everyone taking time to share these results. They are very cool. So I understand having lots of time, lots to want to talk about. Okay, I will go ahead and ask just the one or two questions that we might have time for. I do see one question we have for Lindsay that's been upvoted a few times is regarding some of your research on particulate phosphorus, you know, that being reduced, but where are you thinking about soil reactive phosphorus, especially as that's a huge concern. This Sam Francis is from Ohio, where that's a huge concern.
Yeah, soluble reactive phosphorus, that one does continue to be an area of concern, a harder one to address. I will note for this study, the increase that we saw, that was a result of a manure application this past fall, right before a runoff event. So that was why we saw such high soluble reactive phosphorus in that one. But it does continue to be an area of concern and something we're still looking to figure out what the best way to address it is.
Yeah, I see someone else commenting. It's SRP is a different animal. Sure thing.
Yep.
So this question might be for all of you. I think it's an open question, but it is getting upvoted by Scott Kendall, and he's saying regarding groundwater drawdown, is anyone looking into the loss of groundwater recharge due to excessive tile drainage? Do you know of any? I know that's not currently something that y'all are researching within on farm, but curious if you're aware of any research taking place on that.
I am not aware of anything on that. Wisconsin, we don't have a ton of, we do have some tile drainage, but not as much as a lot of other Midwest states.
Yeah.
In Arkansas, all the drainage is done by the surface, land leveling, land shaping. So we just, our soils have a restrictive zone too close to the surface. Tiles would interfere with some of our practices.
Yeah, no one from like Iowa, for example, that heavily tiled area is on the call today. So that might be something to extend to our colleagues and some of those states. Sorry, we didn't have an answer for you on that, Scott. Okay, I'm going to ask one final question before we button up here. And this is a kind of a question probably for all three of you if you'd want to briefly comment on it. from Tess Van Gorder is that how do you build and maintain that trust with farmers that are participating in these networks to ensure they're likely to continue participating and spread that good word?
I guess I can go first, but I'm pretty new to this yet. But I think we've got some history to the program, and like none of our participating farmers have had any backlash from like the data we've collected. I guess we used to have a written agreement with government agencies that no one was going to get backlash from the data they're collecting because they are trying to do something better. So it's kind of an unwritten agreement now, and we also try to keep them anonymous when we're presenting now. Originally, we had to have some names just to get the credibility of the research behind it, but now we try to protect their identity and keep them their level of comfort.
Yeah, I think for me and for our program over the years, what I've learned is number one, if you say you're going to do it. That's important to farmers. And number two is don't just go visit, get out in the field and work and sweat some, and let them see that you're committed to working hard on their farm. Those are simple things. They're not a scientific answer, but they go a long ways, especially with our farmers in Arkansas, if they know you're willing to invest some sweat on their farm. And then finally, we're just very honest with them. We tell them, we don't know what we're going to find. But if we find something that's alarming, you will be the first to know, and then we're going to work with you to try to find solutions. So those are the three things that we have done.
Yeah, absolutely. Those are big actions. Laura, any final comments on this question?
Yeah, no, I agree with both the others, and just, I guess I'll add, I think really the local relationships or close relationships are really critical. So we really rely within our program on local extension educators, extension agents that maintain those close relationships. And, even in that survey that I mentioned, that was really highlighted by the participants as one of the highlights for them is the networking, the close relationships working with extension educators in their area, and being able to have them, as a resource for other things as well. So it really build the relationship beyond just that project.
Yeah, absolutely. Not coming in and taking over, you're relying on that established relationship. Well, thank you so much. I think those are awesome points for building relationships with farmers in general and with people in general. Thank you for all three of you for taking the time today to join the webinar and to share a little bit about your programming. I know it's tough to get all the information on all that you do with on-farm research and on-farm discovery in 10 or so minutes. So I appreciate you guys being up for the challenge, guys and gals. Everyone, if you had a question, I know we didn't get to all of them today. If you have a burning question for one of our presenters, you can reach out to them specifically. So I put their email up on the screen there. Feel free to email them and let them know if you had a burning question that you weren't able to get answered today live. The other thing I'll just note, as a reminder, this is recorded and we will put this on our website, northcentralwater.org. So be sure to check back there if you'd like to see the recording or share this recording with anyone else within your network. I also want to let you know we do have a webinar coming up next week, Wednesday at the same time through our Soil Health Nexus team. And that's going to be with Augustine Obar. Dr. Obar is out with K-State, and he's going to be talking about grazing, cover crops, and soil health. So if you're interested in learning more about that and specifically encouraging cover crops within dryland systems, be sure to go to soilhealthnexus.org for more information. Thank you all so much for joining us here and have a great rest of your day.